Hey guys, welcome to a BC AP Calculus FRQ review. Today I'm going to be walking you guys through a volume and area and integration techniques problem, and I'm going to show you guys what you can do to full score the given question. Let's get right into it. Let's start with 2022 BC FRQ number 5. This problem is a pretty good problem because you need multiple techniques. I'm not going to spoil what they are, but it makes this problem pretty interesting. So, 5a. We're given two graphs, but let's just focus on this graph for now because this is what we need. So, this graph, R is defined as the area bounded by this curve. Y equals 1 over x, this curve right here. It's also bounded by two vertical lines, x equals 1, x equals 5, and it's bounded by the x-axis. So R is equal to this area. So 5a just asks us to find what R is. So let's see how we can find that. Well, we can write R, or area, is equal to an integral from 1 to 5 of 1 over x dx. Now, let's see what this means. So we have our bound here, x equals 1 and x equals 5. And basically what we're doing is we're taking 1 over x, which is this, and we're adding up all of these. And each time we add it, it's an infinitely small x. We're multiplying it by an infinitely small x. So we end up adding all of these and multiplying it by an infinitely small x an infinite amount of times, and we get this area under the curve. So, an integral of 1 over x. Well, we've seen this many times. And this is equal to ln of x. So, we add the absolute value sign because whenever you get an integral of 1 over x, you need to add an absolute value. In this case, it's not needed, but for other FRQs, this absolute value sign could be essential to solving the problem. So remember to always add the absolute value sign. So, solving by putting in the bounds, we get this. And ln of 1 is just equal to 0, because anything to the power of 0 is equal to 1. So, just equal to ln of 5. So, for the AP exam, you want to make sure you write this statement. R, or area, is equal to integral of 1 to 5, 1 over x dx. And make sure you get this. And also remember, keep the absolute value sign. And yeah, that is 5a. Alright, let's move on to something a little more interesting. 5b. So now, we're still using the same area R, but R is now a base of a solid and we're finding a volume. So at each x, the cross-section perpendicular to the x-axis is now a rectangle with area x times e to the power of x over 5. So we're basically adding up a bunch of rectangles now. And we don't actually need to know the length of the rectangle. All we need to know is that this is the area. So to do this, we write a simple integral. We still have the same bounds. And so this is a common mistake people do. They might use 1 over x or some type of variant of 1 over x, but they already told us that the area is x times e to the power of x over 5. So this is actually pretty simple. We just use what they tell us. So make sure you write this. And this will already score you a point. So now we see that this is integration by parts. So we set this to u and we set this to dv. And this will help us integrate this because we don't have an easy method to integrate like we did for 5a. So using integration by parts, we have this, and now we integrate both sides. So we have v on the right side, and we have 5e, 5 on the left side. So when solving integration by parts problems, you want to make sure you write this out and define all your variables, and this will score you a point as well. So now we just use the equation that this u dv is equal to u times v minus v du. So plugging in, and now we just solve. So plug in 5 here, we get 25e, and plug in 1, we get e to the 1 over 5. And now we integrate this, and the integral of this is just 25e power of x over 5, same bounds. Now we plug in the bounds, so 25e minus 25e to the power of 1 over 5. These cancel because this is subtraction, so we're left with 20e to the power of 1 over 5, because this is negative, and this is addition because there's two negatives. So this is our answer. Make sure you don't make the mistake of using this in your integration and just use what they tell you, and write this and make sure you set up your integration by parts. Let's move on to 5c. So 5c uses graph 2, which is now y equals 1 over x squared, which is this curve, and it's bounded from 3 to infinity. So it starts at 3 and goes to infinity. So C asks us to find the volume when this area, which is bounded from 3, bounded by the x-axis, and this curve is rotated around the x-axis. So this will give us something that looks like this. Rotated all around. So it's kind of like a cone. And basically, we're just adding a bunch of circles. So it's another integral. So the area of a circle, which is what we're going to be adding up, is pi r squared, as we know. And r is going to just be our y value. So that's going to be 1 over x squared. So we write an integral from 3 to infinity, pi times r squared, which is 1 over x squared. This is what you're going to need to write in order to earn one of the points. So yeah, make sure you remember this is the equation for what we're integrating. So now a common mistake is that people see this and they will leave that there, but we can't. For an integral, you can't bound it by infinity, so we take a limit. And this can come out. So take that out, write limit, t approaches infinity. So it's equal to this, we just took the limit. So now we can just solve this. It has to be negative because this is technically x to the power of negative 4. So make sure you write a negative there. And then t and 3. So solving, we get and we do a plus because we're subtracting from the bottom, but we already have a negative here, so 2 negatives is a positive. So this is 1 over 81. And now this, as t becomes infinitely large, as t approaches infinity, this will actually go to 0 because it's 1 divided by an infinitely large number, and it will approach 0 as t approaches infinity. So, and then from here, we just have that it's equal to 1 over 81 pi. So this is our answer. So make sure you don't forget to write the limit and replace this with a variable. Write your initial statement here. And remember, pi r squared, y is your r. And just like that, we've full scored the FRQ problem. Thanks for watching, and if you have any questions, I've linked a bunch of resources, practice problems, and answer keys. And if you have any questions, you can use those to practice. Yeah, that's it.